Hey guys, it's Mr. C, and in this video we're going to be talking about some properties of integer exponents. And so the first thing that I've presented to you is a little graphic organizer that shows all the properties of exponents. So you have the product of powers, which means that when you have two of these powers here, a to the m and a to the n, and the bases are side by side and they're the same, then you just add the exponents. The quotient of powers, when you have two powers with the same base and you divide them, you subtract the exponents. Power of a power, when you have a power and you raise it to another exponent, you take these two exponents and multiply them together. And the power of a product, basically what that means is kind of like a distributive property. When you have a times b, these two bases in parentheses with an exponent on the outside, you distribute that exponent to both of them or everything in here, and everything gets raised to that exponent that's on the outside of the parentheses. Over here you have power of a quotient, which basically means that when you have two bases and they're divided and you have an exponent on the outside, it distributes to the numerator base and denominator base. Anything to the 0 power is equal to 1. And then you have the negative exponent rule, which basically acts like a flipper. A negative exponent will flip your expression, and your base will be in the denominator, or it'll be the opposite numerator denominator than it was. And then if it's just one power like this with this base, it'll be a 1 in the numerator. Or if you have a fraction, it takes the whole fraction and that negative exponent will flip it. And the denominator becomes the numerator and the numerator becomes the denominator. So in these examples, we're going to use all of these properties. And one caveat is that there's more than one way to simplify these expressions, more than likely. And so I'm going to show you one way. I may show you a couple different ways, but if we get into every single way for all these problems, then this video would take an enormous amount of time. So I'm going to kind of do the property or use the property or the strategy that kind of comes to my mind right away. And so the more you do of these, the more familiar you'll get with the properties, and then you'll be able to have in your mind which one you want to use when you come to a particular problem and you have to simplify it or use one of these properties. All right, so let's get to it. And so the first thing we have is 2 to the 15th divided by 2 to the 10th. The last thing you want to do is put this in a calculator, because you're going to eventually get some enormous numbers here when you simplify these. And if you put them in the calculator, it can be done, but if you try that, usually a teacher or a professor is not going to give you any credit, because all you did was use a calculator and you didn't use any properties. So what I like to do is I like to think of stuff like this way. You have 15 2's in the numerator, you have 10 2's in the denominator. I could use my quotient of powers rule, but the better way to think about it is this. If I have 10 2's here and 10 of those 2's are going to cancel with 10 of these, how many would it leave when it cancels them all out? Well, if I use up 10 of them up here, there's still going to be 5 left, right? So 15 take away 10 is 5. And if you use the property, that's exactly what would happen. You do 15 minus 10, and you come up with 2 to the 5th power. Now, if you can take an expression like this and simplify it even further, we generally don't like it to be left like this. If it's 2 to the 5th, we would probably want to write out what 2 to the 5th is, and that's going to be 32. And then that one's done. In college, they'll give you numbers actually here and here, exponents, that will be so big that it'll overflow the memory in your calculator and you'll be forced to use the properties anyway. I've seen that happen many times. All right, so here's our second one. In each one of these, I'll explain which property I'm using. So this time, I'm going to actually use the property that says when I have an exponent here, it distributes to everything in here. So this distributes, that distributes, and that distributes. If you have a number that's being raised to a power, that you want to actually evaluate that. So -3 squared, well, -3 times another -3 is +9. X squared squared, 2 times 2 is 4, so it would be x to the 4th. Y cubed squared would be y to the 3 times 2 is 6. So what's the common misconception here? Well, one thing that people will do is they'll take the -3 and 2 and they'll multiply them, and they'll get -6 right here. And then the ACT, that answer is always going to be there. And here, they'll add 3 and 2 and make 5 instead of 6. And that answer will be on the ACT, or if it's a multiple choice, that'll always be there. This one, if you add 2 plus 2 and then multiply 2 times 2, you still get 4. So that's not really going to separate that out from fact from fiction there. So you just need to remember to multiply these as you go, the exponents, and if it's a number, just raise it to that power. Okay, so 9x raised to that exponent. 9x to the 4th, y to the 6th would be our final answer. All right, let's take a look at this one. Sometimes you'll get expressions with more than one factor in here, and here all of our bases are x, they're all the same, they're all side by side. And so basically what happens is, I'm not going to worry about that -1 as being a flipper. I'm going to take all of these exponents and I'm going to add them together. Plus 0, plus 5. -1 plus 0 is -1, plus 5 would be 4. And so we get x to the 4th. Very common one. Okay, in this one, we have multiple things happening. And I could do this a couple of different ways, but the first thing that comes to my mind is I want to go ahead and I want to simplify the numerator first. I have two bases side by side, so I'm going to add the exponents. So 6 plus 3 is 9, still over x to the 11th. Now let's think about it. If 9 of these x's are going to cancel with 9 of them down here, there's more here. So my final answer should have some x's down here, and they all got used up here. So when they all get used up, there's still a 1 there. 9 and 11, the difference of that is 2. So 1 over x squared is my answer. Now I could have done a quotient rule and arrived at the same answer, and there's multiple ways you could do this. But in my mind, this is the method that would come most naturally after doing so many of these. But you can try a different way. Okay, here we have a couple things going on. First of all, you have this guy right there being cubed. This one's just by itself. And both of these are being multiplied together with these parentheses. So everything's being multiplied together. But I do not want to multiply them first, because that 3 only goes with this. So I'm going to simplify one time first. 4xy squared. And then here, I'm going to actually take that 3 and I'm going to distribute it, just like I did before. So -2 cubed is -2 times -2 times -2. I see students get this wrong quite a bit. 2 times 2 times 2 is 8. And 3 negatives means 2 of them will cancel, but 1 will still be left. So -8 is left after you keep it. 3 times 2 is 6. And then 1, remember there's a 1 there. 1 times 3 is 3. Okay, now I'll go ahead and simplify. I always do the number parts first. 8 times 4 is 32. -32. 6 x's, 1 x, they're side by side. So we're going to add 1 and 6 make 7. 2 and 3 make 5. Don't multiply them there. When they're side by side, you add. The reason why I can kind of pick and choose as I want is because multiplication is commutative, and these parentheses just mean that everything is being multiplied together. So my commutative property of multiplication is still working for me. Okay, in this one, I'm going to simplify the numerator and then the denominator. So let's see what happens. 10 and a -3 make 7. -2 and 4 make 2. Okay, now I can subtract. 7 take away 2 is 5. Or think about it this way. These two are going to cancel with 2 of these, and it's going to bring it down to a 5 right there. And either way, you're going to get x to the 5th. Okay, this one. Okay, this one's going to require us to take this 4 and distribute it to everything in there. So it's going to distribute to this, the 3. Okay, so what's that going to look like? Okay, that's going to be 3 to the 4th power is 3 times 3 times 3 times 3. Okay, that's 81. 2 times 4 is 6. Over, okay, now we're going to distribute this 4 here to those guys. All right. 2 to the 4th power is 16, and 3 times 4 is 12. Okay, now, am I done? 81 and 16 have nothing in common. The reason why, because you started with a 3 and a 2 here, and those couldn't be divided evenly. And since you raised them both to an exponent like 4, it still isn't going to make them cancel anything out. So the 81 and 16 are done. X and Y, they're completely different bases, so they're not going to cancel at all either, and that's going to wind up being your final answer there. Okay, this one. Okay, so now I've got to do it both ways here. This one I've got to go ahead and distribute. And so I'm going to get 4 times 4 is 16, x squared. Now this one's kind of interesting. I see that -2 with this. What I really want to do there in my mind is I want to take this, I want to flip this into a denominator with a positive 2 exponent. So I'm going to use up that negative by putting this guy down here, but putting a positive 2 right there. So now what do? Well, I'm kind of done with the numerator for now, but my denominator, I still need to distribute that 2 to both of these. And so now what I have is 16x squared over 2 squared is 4, and 4 times 2 is 8 for the x. Okay, and I can keep going. Okay, so 16, and I'm going to go ahead and just write my division bar right there, just in case I need it. 16 divided by 4 is 4, so that's going to be in the numerator. Okay, then I have 2 x's up here and 8 down here. So 2 of these are going to get used up with 2 of these here, and it's going to drop that down to a 6. Okay, and there's really nothing I can do with that. If this was an expression to be used, the only thing I would have to remember here is that I can't let x be 0 because then the denominator would be 0. So I kind of, again, still assume that my variables are non-zero or they're positive. Okay, so that one's done. Okay, and these are all very, very common ACT problems too. I like to use those as my examples. Okay, this guy, it's very tempting to start canceling stuff out, isn't it? But you can't. You got to first do this. Okay, so 3 squared is 9. X squared squared, 2 times 2 is 4, over 3x. So now let's take a look. I've got 9 divided by 3, which is 3, right? So let's go ahead and put a division bar. 9 divided by 3 is 3. That 1x is going to cancel with one of these up here, and it's going to drop that down to a 3. Now what happened was everything down here got used up, but it still leaves a 1 there. It doesn't leave a 0. Now you'd never see this answer in the back of the book. What you would see is just 3x cubed, because when we have a 1 in the denominator, it basically goes away and we don't worry about it. So 3x cubed is fine. This one is also okay. I mean, people will accept that, but eventually you'll get out of the habit of putting a 1 in places like this where it doesn't really even matter. That's the back of the book answer right there. All right. And I've just got a bunch of examples that are all a little bit different. Again, this one, I start thinking about combining these. Bases are side by side, so I add 8 and -4 makes 4. 1, that's a 1, and 3 make 4. So if I have the same thing in the numerator and denominator, the exact same thing, that has to equal 1. And so that whole expression right here that look complicated is really nothing more than 1. Okay. This one, I have an option. I can either flip it first, or I can simplify and then flip it. In my brain, I want to simplify this first before I flip it. So let's go ahead and simplify it first if we can. Okay, so let's see what we got. 5 and -1 make 4 because they're side by side. I still have 1x down here, still with a -2. Now you could distribute the -2 if you want to, but I can still simplify that one more time. X to the 4th over x, that's going to cancel with one of these and drop that down to a 3. So what I really have is x cubed raised to the -2. Okay, now let's do our flip. That negative is going to flip this, and when it does, we really need to understand that that's over 1. So what happens is when you flip it, you get 1 over x cubed to the positive 2. And that's our negative exponent rule. Now the 2 is going to distribute both of those. Okay, so what's 1 squared? 1. Okay, you have 3 times 2 because it's distributing. 3 times 2 is 6. And then that's it. Again, you could arrive at this answer way more than 1 or 2 ways. But this is just the method that comes natural to me. And so that's the one I'm going to use. But you can try different ways. All right, let's try this one. Looks like another negative exponent. Okay, this time, I look at this, I don't see anything canceling here. Nothing's going to help me out. All right, so I'm going to just go ahead and flip it right away. So I'm going to put the 5y squared numerator, the 4x in the denominator. I'm going to change that negative to a positive 3 because I used it up by flipping it. Now I'm going to distribute. So I'm going to distribute this first. So what I have now is 5 cubed is 125. 2 times 3 is 6 over, okay, now let's do the denominator here, those two guys. All right, so 4 cubed is 64. X cubed is just x cubed. 1 times 3 is 3. And again, since nothing could simplify here, nothing's going to simplify here at the end either. So this would be your final answer right there. Okay, this one. Okay, can I do anything? I'm looking at this now and I'm thinking this one is kind of interesting because I have negative exponents here and I have a negative exponent here. Let me go ahead and distribute first and see what happens. So if I distribute everything, all right, here's what's going to happen. I'm going to get negative 2 to the negative 2 power. I'm going to write that out. Well, yeah, let me just go ahead and write that out. Negative 2 to the negative 2. Okay, times x to the negative 1 to the negative 2. Negative 1 times negative 2 is positive 2. Negative 2 times negative 2 is positive 4. So now I'm looking at this, and now I have this negative 2 to the negative 2 power. All right, so let's go ahead and let's take this and take the negative 2 and square it first. All right, negative 2 squared is positive 4. So what I really have is I have 4 to the negative 1 times x squared times y to the 4th. Didn't look that confusing at first, did it? That 4 to the negative 1 is going to flip that 4 only. These two guys do not have negative exponents. So what's going to happen is my final answer is going to have a 4 not in the numerator, but down here. I'm going to flip it down in the denominator. These two guys are going to stay up top. And then that's my final answer right there. Okay, let's try the next one. Okay, let's do this one a little different. Let's go ahead and flip it first. There's a lot going on here. Let's flip it first because I don't like all that stuff going on. And you got numbers here and that. So let's flip it first. And we get 4x to the negative 2 over 6x negative 3. And all of that, we're going to change that from a negative 2 to a positive 2. Okay, so we flipped it first. Now what's going to happen? If we flip it first, we can also simplify these right now if we want to. 4 divided by 6 is really 2/3. So we can simplify that. You could also distribute the 2 to everything if you want to. I don't know which one's going to be easier or better. You never know until you just start playing with it. So let's go ahead and let's just do one step where we simplify the 4 and the 6. Whenever you have a chance to make your number smaller, you want to do that. So let's do 2x negative 2 over 3x negative 3. And all of that is squared. So let's take a look at this now. I could distribute my 2's, my 2 here and my 2 there. I could do that. Or these x's both have a negative with it. Since they both have a negative with it, they're going to change places. And so I have really 2x to the positive 3 over 3x to the positive 2. So whenever you flip something with a negative exponent, you use up the negative part of it and it becomes positive. So these two guys flipped, and now we see them flipped, still with a 2 on the outside. Now, let's take a look. I can take the x cubed and the x squared and I can simplify those guys. That 2 is going to cancel with 2 of these and leave 1 x up here. So what I have now is 2x over 3 squared. Okay? So now let's take a look. Now, let's go ahead and distribute this 2 to everything in there, and let's see what happens. 2 squared is 4. X squared is just x squared over 3 squared is 9. So what I would challenge you to do on this problem is do it a couple different ways and just see for yourself which way that you think is faster. Your brain is going to eventually, though, settle on a pattern that it's most comfortable with. And so it's completely up to you. This is just the way I decided to start it out, but I could have flipped these right at the very beginning, couldn't I? That may have helped me out. I would have still had to flip everything anyway because of that negative 2 out here also. But somebody else could have distributed everything right from the start. You still get the same answer at the end no matter what, but you can try that yourself. Okay, this one. Now this one looks interesting because I got 8, 2, and 4 there. Now these 3 bases here are not the same. So technically I can't do anything with that right now. A student is going to, though, want to do stuff like 8 times 2 is 16, and then you got a 4 here. They're going to want to do these things that have absolutely no rule to it. However, I do know that I can take each of these bases and I can turn them all into base 2 because 8 is 2 cubed and 4 is 2 squared. So what I could do is replace the 8 with 2 cubed, still with a 5 out here. The 2 to the 9th is fine because it has the correct base that I want. For those 2 squared, I can replace that with an 11 there. And what I've used is a substitution property. 8 is 2 cubed, 4 is 2 squared, and now I can apply my rule. My rule says that now I can multiply those, and I would now get 2 to the 15th times 2 to the 9th over 2 to the 11 times 2 is 22. Okay, so now you're looking at this and you're thinking, okay, bases are side by side, they're 2's. So now we can take that 15 and we can take that 9 and turn that into a 24 over 2 to the 22. Okay, 22 of these 2's are going to cancel with 22 of these, and it's going to leave 2 of them up here in the numerator. 2 squared, and that whole expression turns out to be 4. But you couldn't do anything until you turn these bases into something that you could use with that 2 right there. And fortunately, we could do that. But if one of these was a 3, then you couldn't have done that. You would have had to have left it because there's no rule for that. Unless you had a common, the same exponent, which we don't. 8, 5, 9, and 11 are all different. All right, so let's take a look at this one. Okay, this one. Okay, so we can do a little cleaning up here with this one. We got 2 different bases, x and y. So let's go ahead and draw that because I don't know what's going to happen. Let's deal with the x's first. You got 5 here and 4 there. So these 4 are going to cancel with 4 of these and leave 1 x sitting right there. These negative 3 right here are going to drop down. It's going to flip down. It's going to become positive, and there's already a 2 there. So when these 3 negatives drop down here, what's going to happen is that guy is going to be right here, and 3 plus 2 makes 5. And now your problem is solved because this, you can't do anything with that, and it's done. Okay, let's try this one. Another one that looks kind of like the last one, so it's good practice. All right, this one is interesting. And sometimes if it gets more complicated, you want to actually add a few extra steps. So let's look at this one. Let's flip our x's first. That x negative 4 is going to go down here. The x negative 2 is going to go up here. So what's going to happen is you're going to get x to the 4th here. You're going to get x squared up here because you have negative exponents. These you can simplify. They don't have negative exponents. 9 of these y's will cancel with 9 of them down here and leave 1. And so now you have x squared over x to the 4th y. So your y's are taken care of, but not your x's. So 2 of these x's now are going to cancel with 2 of these. And what's going to happen now is they're all used up here. And it leaves nothing but a 1, x squared, y. And now it's done. Okay, this one looks like it has a lot going on, so let's check this one out. Okay, so we have a negative exponent here. We've got some negative exponents here. Let's do this. Before we start dealing with the negative 2, let's go ahead and clean up some of this if we can. All right, so negative 6 divided by 3 is negative 2, and that's going to be found up here because 6 is bigger than 3, and so the division of that is going to be still up here. You got x over negative 1, x negative 1. That negative 1x is going to flip up here. There's already 1 there, and it's going to make 2. Okay, y's. You have a negative 1 here, 1 down here. This y negative 1 is going to flip down, combine with that one, and make 2 down there in the denominator. And again, still to the negative 2. Now, I've got everything in the inside of the parentheses cleaned up as far as I can. So now I'm going to go ahead and I'm going to flip it. So I'll write y squared over negative 2 x squared, and all of that to the positive 2. So I used it up by flipping it. Now I'm going to distribute. Y squared squared would be y to the 4th. Negative 2 squared is positive 4. X squared squared is x to the 4th. And now it's done. Okay, so now we're going to deal with a couple problems that have more than 2 variables. These actually have 3. So let's see how this is going to work out. Okay, so let's keep track here. Go ahead and put equals. Let's go ahead and put a division bar there. 5x's up here, 6 down here. These 5 are going to cancel with 5 of those and leave 1. 1y up here, 2 down here. So this 1y is going to cancel with 1 of these and leave 1. 3 z's in the numerator, 1 down here. This one's going to cancel with 1 of those and drop it down to a 2. And then that's it. There's nothing more you can do. Look complicated. The answer though is very simple. And our last example. Throw a number in there. Let's see how this works out. Okay, here's my division. 24 and 16. I'm thinking 8 is a common factor of these, right? 8 goes into 24 3 times. 8 goes into 16 twice. I always deal with the numbers first. All right, 4 x's, 2 x's. How many and where? These 2 are going to cancel with 2 of these and leave x squared. This y, negative 1, is going to drop down and add to the 3. It's going to make 4. 5 z's here, 9 here. So these 5 are going to cancel with 5 of these and drop that all the way back down to 4. And I see that there's really nothing I can do with that. And so my answer for that one would be done. It looks complicated, but the answer again is really not that complicated at all. So hope this helps. Remember to like and share and subscribe to my channel, and we will see you guys later. Bye.